The trigonometry, you have different trigonometric functions, and it is very, very important to know the domains and ranges of the trigonometric functions. First of all, what is the domain of the function? What is the range of the function? Very simple. Domain is the input and the range is the output. What is input? What is output? Very simple. If you switch on the fan, it will rotate. Switching on, we are input. The input is electricity and fan's rotation is output. Switch on the light. Input is electricity, output is light. So, here simply you have to understand whatever the value you give to the trigonometric function is nothing but the domain of the function, and whatever the value you get from the function is nothing but the range of the function. So, whenever a trigonometric function is there, when you take a function, for example, trigonometric function, y is equal to f of x. Let me say, what is that I said about the domain and range? This is input. Understand broadly, it's nothing but the domain. And whenever you give input, there will be output. And output is nothing but the range. Simple understanding. Don't see the domain and range as a violent concept. Very, very simple concept. Input and output. You will be used to these words in your further studies in your engineering and electricity, electronics and electrical subjects, electronic subjects and all this. We will be making use of this input and output. So, mathematically, input is nothing but the domain and output is nothing but the range. So, whenever we consider the trigonometric functions, what is the input? Is there any restriction? And what is the output? Is there any restriction? That's what we are going to see now. Number one is y is equal to sine x. When you take sine x, this x is nothing but the input and y is nothing but the output. So, in input, there is no restriction for sine x. How do we understand that? Sine x is nothing but opposite side by hypotenuse. Opposite side by hypotenuse is sine x. Now, the denominator is hypotenuse. For a right angle triangle, that hypotenuse will never become 0. That means there is no undefined case in case of sine x. That means you can give whatever the value you like. That is, the domain part is x. You can simply say it as set of real numbers. Set of real numbers means minus infinity to plus infinity. Both are same. That means for sine x, it accepts every real number you give. That is, the domain of sine function is minus infinity to plus infinity. Then what should be the range of it? There is a restriction for this, minus 1 to 1. What does it mean? How do we decide that? The minimum value is minus 1 and maximum value is plus 1. And it is common sense that sine x is opposite side by hypotenuse. When you take sine x opposite side by hypotenuse, hypotenuse is always greater than the opposite side. That means it is always an improper fraction. It's always a proper fraction. That means denominator being greater, and hence the value will be always lesser than 1 and it will be greater than minus 1. So, the range of sine x is always lying between minus 1 plus 1. Similarly, for second function cos x also the same. The domain is set of real numbers or minus infinity to plus infinity, and the range will be minus 1 to plus 1. So, for all the medical purposes, sine function is used because whenever the body functions are to be measured, like pulse rating, heart beating, and all these are to be connected to a continuous function, and also that should be visible on the device. That should be visible on the device. What I mean to say, visible on the device means y-axis is vertical and horizontal is x-axis. This is domain is horizontal, that is x-axis, and the range is nothing but y-axis. Understand that. So whenever you give an input, whenever you give a value to x here for sin x, it accepts and gives a value lying between -1 +1, which is very much visible on y-axis on the vertical side. So horizontal values are given and that will be converted onto vertical side. So vertical always graphs lies between -1 +1. I'll show you the graphs also. So because it is very much visible on the instrument lying between -1 +1 and it accepts every real number, that is the reason why sine function is used in the medical purposes like ECG and the hospital instruments, whatever the medical instruments are there. In that one, the function used is the sine function. So why not cos function when it has same domain, same range here? The cos 0 is 1. That means it will not pass through 0, 0. It passes through 1, 0. 0, 1, 0, 1. But it passes through 0, 0 because sine 0 is 0. It passes through 0, 0. So sin x graph passes through origin here. So there will be a reference point. It passes through 0, 0, and hence the measurement will be easy for sin x. That is why sine is used for medical purposes more. Whenever it is a continuous function is needed, in that case sine will be used. Next, coming to 3, tan x. Tan x, as you know, is nothing but sin x by cos x. When sin x by cos x is taken, it won't be accepting all the real numbers like sin and cos does. But in this case, the denominator is containing cos x and you should not give those values to x, which makes the function undefined. And hence, what are the values that are not to be given to tan x here? That will be decided like this. So take the denominator is cos x there. So you should not give those values to cos x. That makes the function 0. That means when cos x becomes 0, let us check it out. When cos x becomes 0, it will be like it becomes 0 when x is equal to pi by 2, x is equal to 3 pi by 2, x is equal to 5 pi by 2. For all odd multiples of pi by 2, cos becomes 0. Understand that. That means here this is not the value accepted by the tan function. So x is not equal to 2n plus 1 into pi by 2. N belongs to z. Understand that. Any integer. N belongs to any integer. So accept these values. Tan function accepts every real number, and hence you should not give those values to x there. You should not give those values to x there that are not acceptable by the functions. That is, you can give any real number except, why I am saying except here, how I am showing except here, minus, I put a minus there. That means give every real number except those values to x such that your x is equal to 2n plus 1 into pi by 2, and this n belongs to any integer. So there is a restriction for tan x unlike sin x and cos x in the domain of the function tan x. So these values should not be given. It is common sense that why these values should not be given when x becomes pi by 2, cos pi by 2 becomes 0, and thereby the denominator becomes 0. When the denominator is becoming 0, tan function is undefined, and hence we are avoiding that value. So these values are not given except those values. All the values can be given. Now coming to the range will be set of real numbers only. Just to see this. Now you will better understand the domain of sin x and the domain of cos x and the domain of tan x. These are the three different trigonometric functions you can understand. Now coming to the remaining three. What are the remaining three functions? Now if you take cot x, it's a reciprocal of tan x. Reciprocal of tan x means you will get cos x by sin x. So how to decide the domain of cot x? Then you will get for cot x cos x by sin x, denominator will be sin x. You should not give those values to x there in cot x, which makes sin x 0 because it is a reciprocal. Sin x becomes 0 when x is equal to pi, x equal to 0, pi, 2 pi, 3 pi, and so on, n pi. For all integral multiples of pi, sin x becomes 0 because the denominator of cot x is containing sin x. You should not give those values. So there will be restriction in the domain of tan x, and there will be restriction even in the domain of cot x also similarly. So let me show you that. That is for cot x here, cot x. Let me write the domain of cot x. That is, we should not make use of those values of x which undefines the function, So cot x will be in this way now. It will be fourth function, what I am writing here, y is equal to cot x. In every case, it is set of real numbers only, but there are some restriction for some functions. What are the restrictions here? You should not give those values to x, which makes the function undefined. So here, what are the restrictions for cot x? Cot x should not become undefined for some value of x. What are those values here? And cot x is nothing but cos x by sin x. In this case, we made cos x not equal to 0. In this case, you must make sin x not equal to 0. That means you should not give those values to x, r minus x such that x is equal to n pi, please, n pi. N belongs to z. See the difference here. See the difference. It is of a very odd multiple of pi by 2 not given. Here any integral multiple of pi is not given. And coming to the range of this, range will be set of real numbers only, that is minus infinity to plus infinity. Coming to the fifth one, the reciprocal of cos x is secant x, containing cos x in the denominator. So a simple understanding here, cos x is in the denominator of secant x and cos x is in the denominator of tan x. So your cos x here is not equal to 0. Obviously here also cos x not equal to 0, and hence the domain of tan x is same as the domain of secant x. So it will be r minus x such that x is equal to 2n plus 1 into pi by 2, n belongs to z. Okay, now secant x, whose reciprocal is secant x here? Whose reciprocal is secant x? Cos x reciprocal is secant x. And cos x always lies between minus 1 plus 1. Cos x always lies between minus 1 plus 1, and its reciprocal never lie between minus 1 plus 1. That means it lies between minus, never lie means we have to subtract this part from this one, or it can also be written as, for your better understanding, it can also be written as minus infinity to minus 1 closed, okay, union 1 to infinity. Just say this. That means it won't be taking the values lying between minus 1 plus 1. Because it lies between minus 1 plus 1, it is a reciprocal, never lie between minus 1 plus 1. Remember like that. Remember like that. Cos x and sin x lie between minus 1 plus 1. Their reciprocals never lie between minus 1 plus 1. That means the values lying between minus 1 plus 1 are subtracted from the set of real numbers. Now, the sixth function, as you know, is nothing but y is equal to cosecant x. Whose reciprocal is cosecant x? Sin x reciprocal is cosecant x. So, you can see sin x is in the denominator of cot x and sin x is in the denominator of cosecant x, and hence the domains of these two are same. So, r minus x is such that x is equal to n pi. This is same. And sin x reciprocal is cosecant x. Sin x lies between minus 1 plus 1 and the cosecant x never lie between minus 1 plus 1. So, r minus of minus 1 plus 1. So, the hint here, which is important for the objectives, particularly conceptual questions, it is important to remember the domains and ranges of the functions. That is why I taught you this with a logic to remember. That is, sin x, cos x will have same domain, same range. Tan x and cot x will have the same range set of real numbers. And tan x domain and secant x domain are one and the same. Just check it out, because the denominator of both is cos x. Similarly, the domain of cot x and cosecant x will be same, because the denominator of both is sin x, and the ranges of secant x, cosecant x are one and the same. That is, they never lie between minus 1